All right, so our day 4, we are looking at composite figures. Our composite figures is what we do when we put multiple shapes together to form one picture. So if I look at our first one, nope, not number 2, number 1. If I look at number 1, I have this shape that kind of looks like a pencil. And that pencil is created by putting together 3 different shapes. If I look at this shape that's kind of the eraser, we have a semicircle. Semicircle is just half of a circle. So I think about our circle formula is pi r squared. So if I want a semicircle, which is half of a circle, I just take that and I divide that by 2. The middle piece here, well, that's just going to be a rectangle. So I'm going to add together the area of my rectangle, and a rectangle is nice and easy, just base times height. And then we have the top part of our pencil. When we look here, the top part of our pencil is a triangle. And we know that the triangle formula is 1/2 base times height. So to create this pencil shape, my composite figure, I have to put all 3 of those areas together. So we first look at our semicircle. If I'm looking here, the only variable that I need is my radius. Now I'm given that it's 4 from top to bottom, but remember, a radius is from the center to the outside. So if it's this 4 from top to bottom, that means it's 2 and 2, because top to bottom would be the radius, or the diameter. We cut that in half. So we have our radius squared divided by 2. 2 squared gives us 4 pi divided by 2, which ends up being 2 pi centimeters squared. In the middle, we have our rectangle. Again, here we see it's going to be base, which we're given, 14 times the height, which we're also given here. Now it may be over there by the eraser side, but we know the height of the eraser is the height of, it's the same distance from here to here. It's a consistent figure. It doesn't change shape. It's not going to taper down here. So my height here is going to be 4. 14 times 4 is going to give me 56 centimeters squared for that rectangle. And then we have our triangle. So we have this base and height again, and we know that the base and height always run perpendicular. I'm given, again, this is going to be 4. This right here, it's from here to here, which is from the base to the tip, which is going to be perpendicular. So we were given a base of 4 with a height of 6. So my triangle was kind of turned over on the side here. The base isn't 6 and the height's not 4. The base is 4 with a height of 6. We're looking at those pieces that run perpendicular. 1/2 of 4 times 6 gives us 12 centimeters squared. So when we want to find the area of this total composite figure, we have to take the eraser plus the body of the pencil plus the tip of the pencil. We need to add those pieces together. And when I go to add them together, I notice that this one has a pi. This one's not like terms. These are just numbers. So 56 plus 12, that's going to give me 68 plus 2 pi centimeters squared. This is what we consider an exact answer. Pi is an irrational number. We know it's 3.14, blah, 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 blah. We leave that because it's irrational. If I ask you to round it, then you just go ahead and enter that into your calculator. You add the pi symbol in, so 68 plus 2 times pi, and we get about 74.3 centimeters squared. So it's all about, do I want exact or do I want to round? And that'll just depend on what the directions tell you. Another kind of composite figure isn't about putting things together, but taking things out. So if I look at this figure, if I want to find the area of just the shaded region, I see to find this shaded region, that's what's left over. it's left over from taking the area of the rectangle, and I want to take out those 8 circles. And then that would leave me with the shaded region. So I look here, my rectangle, the dimensions, because a rectangle formula is base times height. We've got a full base length of 16 times a height of 8. So 16 times 8 is going to give me 128 inches squared. And what we want to do is we want to take out these 8 circles. The area of a circle is pi r squared. So we've got a little bit of work we need to do here, because I didn't give you the radius of the square. But if I look at these circles, we're going to assume all of the circles are the same. So I'm going to divide my 8 into 2 circles, which means that this has a length of 4 and this has a length of 4. But those are my diameters. If I want a radius, 4 as a diameter means that each of them have a radius of 2. And I could have used that going this direction as well. If I have 16 divided by 4 circles would have shown me that each of these would have had a length of 4 to get to 16, and then cut that in half to get 2. So the area of one circle is pi r squared, which gives us 4 pi. But remember, we're taking out 8 of those circles. Oops. I got ahead of myself there. So it's 8 times 4 pi, which makes that 32 pi. Now, when you are taking things out, remember, it's the big piece minus things on the inside. So I want the area minus the circles. The order of the pieces matter when we're subtracting. And in this case, inches squared. Remember, this is the exact. If I want to round it, I enter all of that into my calculator and get 128 minus 32 pi, which would be about 27.5 inches squared. Okay, so that's your composite figure. Remember, it's about taking your pieces and putting them together or finding what's left when you subtract pieces out.